Students, this is our first video lecture of Mathematics Paper 1, Calculus of Several Variables. Let us begin with the first chapter, Function of 2 and 3 variables. Two and three variables. So, what are the contents of this chapter? First, we will define a function of two variables. Definition. Then we define limit and continuity. So in the first year, calculus course, what we have learned is same concept for a function of one variable. Function of one variable is studied with respect to these properties: continuity, limit and continuity, then second, differentiability, and mean value theorem. It is derivative, and we have done mean value theorem for a function of one variable, Lagrange's mean value theorem, Rolle's mean value theorem, Cauchy's mean value theorem. Then successive differentiation. That is finding the nth derivative of y. Y is given, to find yn. Then we have studied series, Taylor series and Maclaurin series for f of x. For a function of one variable. So similarly, this year we will study similar So here we will study similar concept for a function of two variables. So first we will define a function of two variables, then we define limit and continuity, limit continuity. Then we will define a partial derivatives because it is a function of two or more than two variables. So instead of one there are more variables. So we can differentiate with respect to each one of these variables. So it is called partial derivatives. Derivative with respect to each of the variables in the function. Then Schwarz theorem and Young's theorem. Schwarz theorem and another is Young's theorem. There are some conditions under which these two partial derivatives are equal. Second order, partial derivative at the point AB, and this is also second order partial derivative at AB. Here in the denominator the order of differentiation is different. That is, here we differentiate with respect to y first, then with respect to x, whereas here we differentiate with respect to x first, then with respect to y. On this side we differentiate first with respect to y and then with respect to x. So this is the equality at a point AB. So these are the things we will study in the first chapter. So let us begin with the definition. So what we will do, we define this function f from R cross R to R. Now what is R? First we will see what is R. We know the set of real number. The set of real numbers. What are the numbers on this line? And how many numbers are there? We will see these things. Now, so what are the points on this line? So 0, plus 1, minus 1, plus 2, minus 2, then plus 3, minus 3. So the numbers are 0, plus 1, minus 1, plus 2, minus 2, and so on, plus 3, minus 3, and plus 4, minus 4. These are the numbers. Now, these numbers which we have written are called integers. This Z is a set of integers. So we have represented these integers on a line. Right? So these are. Is there any number in between 0 and 1? So what we will do? And how many numbers are there? So there are infinite numbers in between any two of these integers. So take 0 to 1, there are infinite numbers. 1 to 2, again there are infinite numbers. 2, 2, 3. On any interval, there are infinite numbers. Let us see how. Consider this interval 0 to 2. This interval 0 to 1, and then we will see 1 to 2. So what we will do is 0 to 1. This is this line 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9, and equal parts. How we have? We get 10 equal parts. The length is 1. So first this is 0, this is 1, this point is 0, this point is 1. So 1 minus 0 is the length, and this length we have divided into 10 equal parts. So we get 1 upon 10. So the length is 0.1. So first interval is 0.1, 0 to 0.1, then again 0.1, and the length, this length is 0.1. 0.1 plus 0.1, 0.2. Again this length is 0.1, so 0.3. 0.3 plus this length is 0.4, and so on. So we have divided this interval into 10 equal parts. There are numbers in between 0 and 1. Similarly, you can divide 1 and 2. Look at this. This is 1, this is 2, and 1, 2 is also divided into 10 equal parts. So again the same length is there, because this is also an interval of length 1, 2 minus 1 divided by 2 minus 1 divided by 10. Again same length is there, 0.1. So add 0.1. So 1, this length is 0.1. So 1.1, this length is 0.1. 1.1 plus 0.1 we get 1.2, and so on. So we can divide any unit interval into 10 equal parts. So we have these are the numbers in between 0 and 1, which we have obtained by dividing the interval 0, 1 into 10 equal parts, and here 1 to 2, this interval is divided into 10 equal parts. Next, what we will do, out of these 10 intervals, consider this first interval and divide it again into 10 equal parts. Find the length and divide it by 10. We can divide it into 10 equal parts. Similarly, 0.1 to 0.2, this can also be divided into 10 equal parts. So next we will see this figure. Look at this. So this is 0, this is 0.1, and it is divided into 10 equal parts. So the length is 0.1 minus 0 upon 10. 0.1 upon 10 is 0.1 is this length. 0 plus 0.01 is 0.01, 0.01 plus 0.01 is 0.02, 0.02 plus this length is 0.01, 0.03, and so on. So 0 to 0.1, this interval can also be divided into 10 equal parts. Right? Similarly, this interval 0 to 0.1 we have divided into 10 equal parts. 0.1 to 0.2 can also be divided into 10 equal parts. So this is your 0.1, this is your 0.2, and we are divided into 10 equal intervals, each of length 0.01. So 0.1 plus 0.01 is 0.11, plus 0.01 is 0.12, and so on. Now each one of these intervals, each time we are getting 10, and take any one of these interval and divide again it into 10 equal parts. Now can we divide this first interval 0 to 0.01 into 10 equal parts? So we can divide, and 0.01 to 0.02, this interval can also be divided into 10 equal parts. So how many points are there in between 2? any number of points can be obtained. So this is the which interval 0 to 0.01, small interval 0 to 0.0. We have divided into 10 equal parts. How again? This minus what is the length? 0.01. This from this to this point minus 0 upon 10. So what is the length? This is A, this is B, the length is B minus A. So here the length is here the length is 0.01 minus 0 upon, and we are dividing it into 10 equal parts. So 0.01 divided by 10. So the length of every interval will be 0.001. Look at this, 0 plus 0.001 we get 0.001. Again this is 001 we get 0.002. Again this is 0.001 we get 0.03 and so on. So each interval can be divided into 10 equal parts. So this is 0 to 0.01. Now 0.01 to 0.02 is second figure. 0.01 to 0.02 can also be similarly divided into 10 equal parts. So what we are doing, every time we have take any unit interval divided into 10 equal parts. We have selected 0, 1 divided into 10 equal parts, then take one interval of this and divide it again into 10 equal parts, then take one interval from this and again divide it into 10 equal parts. So this is a 0 to 0.01 we have divided into, this is 0 and this is 0.01. We are divided into 10 equal parts. So when you divide it into 10 equal parts, again take any one of these intervals. So we have selected say 0 to 001. So this is now this next figure, 0 to 001. This can also be divided into 10 equal parts and so on. So any interval if you take, then select this interval, again divide it into 10 equal parts. So you can divide it and continue this process. So how many points are there? Infinite number of points in between any two, infinite number of points in any interval of finite length. That is, if your interval is 0, 1, it contains infinite number of points. And all these points are elements of the set of real numbers. All these numbers are real numbers. All the numbers which we have written here are all real numbers. These are all the real numbers. So initially we have started with these numbers, set of integers, and it contains 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3. Then we have divided 0, 1 into 10 equal parts. Take out of these 10 equal parts, take any one and again divide it into 10 equal parts. Here also 1 and 2 we have divided into 10 equal parts. Select any one, again divide it into 10 equal parts. You can divide it. Then from those 10 intervals, again select one interval and divide it again into 10 equal parts. So in this way, we can have any number of points in between the two numbers. So there are infinite number of points in between any two numbers. And all these numbers are the numbers from this set R. So R contain all these numbers. So the set of real numbers we have seen. Now what is x-axis and y-axis? X-axis, y-axis. X-axis is also a graphical representation of the set R. What is it? Graphical representation of the set R. Similarly, y-axis is also a graphical representation of the set R, set of real numbers. So whatever numbers we have just seen are all there on the x-axis and as well as on the y-axis. Now let us see this. This is x-axis. So in between 0, 1, these are only integers are shown on this x-axis. Actually, this is a set of real numbers. In between 0 and 1 there are infinite number of points. In between 1 and 2 there are infinite number of points. In between 2 and 3 there are infinite number of points. Similarly, y-axis is also a representation of the set of real numbers. So in between 0 and 1 on the y-axis, again there are infinite number of points. In between 1 and 2, again there are infinite number of points. In between 2 and 3, there are infinite number of real numbers in between 2 and 3, and so on. Points mean numbers. In between any two of these real numbers, there are infinite number of real numbers. So x-axis is the graphical representation of R, and in between any two real numbers, there are infinite number of real numbers. Infinite number of points mean infinite number of real numbers. Take any two real numbers and we will find that there are infinite number of points. That means infinite number of real numbers in between those two. Alright. Now next we will define A cross B, the set A cross B. This set A cross B. What is A cross B? It is called Cartesian product of two sets A and B. Now what is this set? For example, suppose A is the set, A is the set 1, 3, only two numbers or two elements, set having only two elements, and B is another set with three elements, so 2, 4, 5, or you can select the letters small x, y, z or A, B, C, D. Then what is the A cross B, the set A cross B? Then what is A cross B? By definition, A cross B contains order pair x, y, where x is from the first set. First, there are two sets. This is first set in the Cartesian product. This is second set. So In the order pair, first element will be from the first set and second element is from the second set. So therefore what are the elements in the A cross B? So we write down the order pair. First element from the set A is 1, and with this, in this order pair we write second element from the set B. So it can be 2 or 4 or 5. If it is 1, can be paired with 2, can be paired with 4, it can be paired with 5. Similarly, first element, let us take as first element as 3, and second element from the second set B. So 3 can be paired with 2, 3 can be paired with 4, 3 can be paired with 5. So these are the elements of A cross B, Cartesian product A cross B. Now, in the definition of function of two variables, we will use the set R cross R. What is R cross R? The set of all order pairs xy such that first element is from the first set R, second element is from the second set, and both sets are same. So we write here that x and y are elements of the same set R. So R cross R will contain this order pair like this: x comma y, and x and y are the real numbers. We are just seeing the set R. So there are infinite number of points in R, or infinite real numbers. So x can assume infinite number of values, and similarly y can also assume infinite number of values from the set R. And this is an order pair formed by using these values. So there are how many ordered pairs? Infinite number of ordered pairs in this set R cross R. It contains infinite number of ordered pairs. I will show you the xy plane. This is your xy plane, and if you see, you can have infinite number of points in the xy plane like this. So this is a set R cross R. So R cross R means entire xy plane. This is your xy plane. Now, before giving a definition of the function of two variables, let us consider this expression. Fx comma y is equal to, this is a function of two variables. We are not given a definition. It is an expression for a function of two variables. Fxy equal to, say, x into y upon x square plus y square, and xy whenever is not equal to this one point, it is which point? Origin. This point is the origin. Except origin, it is x into y upon x square plus y square, and at origin, at this point, At origin, its value is 0. Consider this expression. Now, this expression, what it does? It assigns this function or this expression, what it does, or this relation, assigns to each order pair xy a unique, take each order pair and you will get a unique number, real number. How? For example, f of 1 1, our x will be replaced by 1, y will be replaced by 1, both variables taking same value. So it is x into y, so 1 into 1 upon 1 square plus y square, that is 1 square. So 1 into 1 is 1 divided by 1 square is 1, 1 square is 1, 1 by 2, it is 0.5. Similarly, if you find f1 comma 2, that is replace x by 1, y by 2, you get 1, 2 upon 1 square is 1, 2 square is 4, so 2 into 1 is 2, 4 plus 1 is 5. So this is point 4. So what it does for each order pair xy does for each order pair xy, this expression or relation associates or assigns a unique real number, a unique real number. Here, to this order pair, it assigns a unique real number 0.5. Here, this expression assigned to this order pair a unique number 0.4. It cannot be another number. It is unique. For 1 and 2, if the order pair is 1 2, you will get this value. Right? So it is unique. What we have written is a definition of a function of two variables. So therefore this is a function of two variables x and y. So what is the definition? Definition: function of two variables so a relation or expression, or what do you say, expression or rules f from the set R cross R to R What is the meaning? The meaning is it takes this order pair 1, 2 and we get a real number for this order pair. So finally, if xy is an element here, for example 1 and 2 is an element here, and for this 1, 2 it assigns a value, which value we have seen that this is 0.4. So 0.4 is a real number. So from R cross R, this is a set of all order pairs. Any expression from this set to this set of expression or relation R cross R is a from R cross R whole x by R, and resultant is a real number. So any relation which associates or assigns, which associates to each element of R cross R, to each, this word is important, to each element x comma y is the element of R cross R. So to each element of R cross R, a unique real number say z, this is your z, 0.4, some say z1, this is say z2, like this. So unique real number say z, it is not a complex number, it is just a symbol, some real number, it is a real number. We have written it is a real number from the set. So a relation f from R cross R to R, which associates to each element xy belonging to the R cross R a unique real number. What it does? This relation associates to each element of R cross R a unique real number. So this word, these two words, each and to each element it is assigning a unique real number, is called a function, is called a function of two variables, function of two variables